This is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please do not share personal information during the session for your own security reasons. All right, at this point, we should have our ticket open. The link is in the chat box along with the password. Remember, if you are watching the recording, the password is not included because it is only in live class and it is 10% of your grade coming to the live classes. There are only 17 days left of the quarter. The countdown is getting more and more nerve-wracking. But today we are talking about levers. We're going to do a pretty easy lab, so you will definitely do really well on this one. So we'll make sure we knock that out of the park today. And tomorrow we do have an extra credit game, so make sure that you come and play our game with us. Give me a smiley face if we're still good with Kahoot games. Give me a thumbs down if we're like, we need something new. Okay. Majority rules, so if we all are feeling pretty good about it, then that's what I will keep doing. Awesome. Okay. So we've been talking about work, right? We talked about the ability to do work. We've talked about simple machines, different things that influence force, and specifically in our simple machines, we talked a lot about pulleys and levers, and today our lab is going to go over levers. So that being said, our objective for today is to understand the relationship between the distance and mass on each side of a lever. And again, we are working on a lab today, but it's not a scary lab. We are going to do really well on it. So let's do a quick review. Simple machines such as levers, they do not change the amount of work. All right, when you're trying to move an object, the amount of work you do is always the same. What they do is they change the amount of force that you need to do in order to get that work done. So if you have to use less force, does it feel easier or harder? Tell me in the chat box. If we have to use less force to pick up an object, is it going to feel easier or harder? Yes, exactly. So if we can use a simple machine to make it less force, then is going to feel much easier. Okay, so that is what simple machines do. But again, in total, the amount of work we do is still actually exactly the same. And the reason for this is because you can't just make the work disappear. You can't reduce the work. The only thing we can do is we can make it feel easier based on the force. Smiley faces if that makes sense. Smiley faces if we understand that. Excellent. Okay, this is number one in your attendance ticket. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Fill in the blank, please, and save. Excellent. All right, let's go ahead and move on. So the next thing that we need to review, which is a lot about what today is going to be about, is remember this idea of mechanical advantage, meaning mechanical advantage is just how easy it is to move an object, right? So if we increase mechanical advantage, we increase how easy it is. And the way that we do this is, again, by being able to use less force, right? Less force means we have higher mechanical advantage because it's easier. Smiley faces if we understand this statement right here. Less force means we have higher mechanical advantage because it's making it easier. Okay, so we have an equation that we're going to be taking a look at today at the end of the lab. I'll go over it with you so it's not hard, but this equation helps us figure out the force that we would need for a person to input if we want to figure out how much they would need to use in order to lift an object on the other side. So remember that work is force times distance, right? So work, smiley faces if you remember that, work equals force times distance. Work equals force times distance. Okay, so here's where we get this equation from, okay? What you can see here is that on one side, you can see force 1 times distance 1. So what we're saying is on this first side, the work of object number 1 is going to equal, on the other side, the work of object 2. And that should make sense to us because what we just said is that we cannot change work. Work is always the same. So the work that I do is still going to be equal to the work I would have to do even if I wasn't using a simple machine. Okay, so again, what we're going to see is force times distance of one side is going to equal force times distance on the other side. So take a look at our lever down here. So what we're trying to do is we're trying to figure out the input force, the force that you would need to use in order to lift up this object. You are super far away from the fulcrum. You're 2 meters away from it. And on the other side, we can see that this object is only 1 meter away from the fulcrum, but it weighs 10 newtons. So we're trying to figure out how many newtons do we need to use at 2 meters away to lift this object. Smiley faces if you understand where I'm going with this. Smiley faces if you understand this diagram, what we're looking at right now. Awesome. Okay, so let's go ahead and label these things right now. So again, we're trying to figure out the force that we need to input on side number 1. So this is going to be our force number 1. F1 is what we're trying to solve. 2 meters, what is that going to be? Tell me in the chat box. 2 meters, what's that telling us? Is that telling us F1, D1, F2, or D2? Tell me in the chat box. We are on the first side, and we're using the unit meters. So does that tell us force or distance? Again, and on which side? Side 1 or side 2? Awesome. I see Sally typing. I see Ariana typing. I see Sophia typing. Make sure you're participating. It's totally fine to guess, guys. This is our first time doing it, so don't feel like you have to get it perfect, right? We're just doing our best to learn this. Yeah, so 2 meters definitely tells us that this is a distance for sure. And it's on the first side, so is this D1 or D2? Tell me in the chat box. Will this be D1 or D2? Awesome, yeah, you guys got it. This is totally D1, exactly. Now on the other side, okay, we can see another distance here. The object is 1 meter away, but this time this one is going to actually be D2 because it's on the second side, the other side. And this object weighs 10 newtons. So if we were to just lift up the object as is, we would have to use that same amount, 10 newtons. And newtons tells us what? What is this one? F1, D1, D2, or F2? What do you guys think this object is here? F1, D1, D2, or F2? What do we think? Yeah, this one's going to definitely be F2, exactly. So the force we would need to lift the object just as it is 10 newtons. So that's our force, but it is on the second side, so it's F2. Okay, let's go ahead and fill in the blanks, right? So F1, we don't actually know this one yet, so I'm just going to keep it as F1. D1 is our 2 meters. F2 is our 10 newtons that we just looked at on our red box. And D2 is our 1 meter on the red side, the second side. Okay, so let's go ahead. We need to figure out how to solve this. So can I multiply F1 times 2 meters? Can you multiply a variable times a number? No, so we're just going to keep that the same, right? We're going to keep this F1 times 2. What about 10 times 1? Can I multiply 10 times 1? What does that equal? What does 10 times 1 equal? Yes, you got it. Can't trick you guys. That's going to equal 10, exactly. Now, here's the thing, guys. Remember that anytime we have something next to a variable, we need to get rid of it by doing the opposite function, right? So if I'm multiplying by 2, I'm multiplying this variable by 2, what would be the opposite of multiplying by 2? What would be the opposite of multiplying by 2? Yeah, we need to divide. So we're actually going to divide by 2, and that's going to get rid of it on this side. But whatever I do to one side, I also need to do where? Whatever I do on one side, I also need to do where? Looks like lots of us know. What do we think? Yes, we need to do it on the other side. So I also need to divide by 2 on the other side. Okay, so on our left side, right, we got rid of everything next to our variable, so now all that's left over is F1, right? So all we've got here is F1. And on the other side, what is 10 divided by 2? Let's solve this. What is 10 divided by 2? Yes, 10 divided by 2 is going to be 5. And force, what units do I use with force? Whenever I have forces, what units should I use? Don't have naked numbers, we need to put some clothes on them. What units do I use with force? We had an example down here, right? F2 was 10 newtons, so what unit should I be using? Take a look at the unit following the number. Yeah, I should be using newtons, exactly. So this is actually 5 newtons. Give me a smiley face if that makes sense, okay? I know it's a little bit of algebra, but it's still pretty easy algebra. We just got to go through the steps and make sure it makes sense. Perfect. Okay, so that helps us understand that this person only needs to use 5 newtons in order to push down on this lever to lift the object on the other side. So that being said, guys, does this person, when they're far away, do they need to use more or less force? When they're far away from the fulcrum, do they need to use more or less force? 5 newtons compared to the 10 newtons on the other side. Are they using more or less force? Yes, so again, remember guys, what we learned yesterday is that when we have more distance means that we're able to use less force, which makes it easier, right? Making our mechanical advantage better. Smiley faces if that makes sense. Smiley faces if that makes sense. This is a super important concept for today. Super important concept. Excellent. All right, guys, let's go ahead and actually jump into our lab. That's really the background that we need in order to understand our lab today. So if you're watching the recording, you need to go to the Content tab, scroll down on the left side where it says Unit 6 Work, and then once you're there, you can scroll down and find the 6C lab. Once you find that, go ahead and click Start Quiz in order to open up your lab. Those of you in class, though, I'm going to go ahead and just send you the link. So here's the link in the chat box. Please go ahead and open that and give me a green check when you have it open. All right, so green checks when you have your lab open. Okay, you are going to have your notes and your lab report open at the same time. But for now, you should have just saved your first notes answer, and we're not going to look at that again until the end of the class. Just make sure you have your notes saved, kind of minimize it out, don't close it, just make it smaller, and then we're going to focus on our lab right now. Green checks when we have our lab open, please. Excellent. Thank you, Andres. Thank you, Andrew and Andrew. Brianna, Sienna, thank you so much. Edgar, Grant, appreciate it. Looking good, just waiting on a few more green checks. Awesome, thank you, Adrian. Anthony Z, let me know what's going on. I see you're typing. Let me know if you're having issues opening it. Dalen, Dolly, Eric, Haley, Jacob, Kim, Maya, Melissa, Michael, Siva, and Zoe O. Green checks if we have our lab open. Oh, okay, it's totally fine, Anthony. As long as you saved your answers, it'll still be there for when we go back to it at the end of class. And if you lost it for some reason, it'll be in the recording, or if I have some time, I will go ahead and tell you what it was at the end of class, okay? Dolly, it's right here in the chat box, okay? Sorry, these directions are just if people are watching the recording. But since you're in class, you get the link. The link is in the chat box. All right, looking good, guys. Oh, I'm sorry, Ariana. Okay, Ariana, make sure you have your answers saved for your attendance ticket, and then you can just close it and go back to it at the end of class. Okay, as long as you have your answers saved and you remember the password, you should be totally fine. Okay. All right, guys, so here's the password again, Ariana. I'm going to go ahead and share with you what we're working on up here. All right, so give me a moment to jump up here. No, don't be scared. We're gonna actually do a lot of the data together. Okay, so you will definitely at least get a 50% because we're gonna do half the lab together. So let me go ahead and share this with you. All right, here we go. All right, smiley faces if you can see my screen up here. The link to the lab, it's already in the chat box, Dolly. It's in there several times. Hold on, let me get it again. Here we go. Here's the lab again. Okay, open that up, please. All right, good. All right, so I'm going to go ahead and navigate to the lab. So I'm clicking Unit 6. Right, scrolling down until I find 6C. Right, and here's my lab. And again, when you click on it, you see a button that says Start. Right, so I'm going to go down here and click Start to open that up. All right, so we're in the lab now, and we are ready to start. Okay, so the first thing is, if you guys do forget any of the information, it will be in the recording once I upload it. So don't freak out. The instructions will still be here for you. You'll just need to wait for the recording to be uploaded. This link right here is super important though. This is the link to the actual virtual lab where we're going to do the experiment. So you want to make sure you click on that link so that you can go ahead and actually open up the lab. Now, I know it's really tempting to try to do everything at the same exact time. It can be a little bit tough though if you're trying to watch and do something at the same time. So I really recommend try to watch first and then you'll have time later to work on it yourself, okay? Once we are here, you do need to click on where it says Balance Lab. So I'll send this link to you directly right now. No worries, Annalise, I'm glad you're here. Okay, just make sure you open up your lab. So here's the link directly to this part right here, but again, it is in your lab report. It's the second link right here, okay? But when you're here, you're going to go ahead and click on where it says Balance Lab, and that is going to open up what we need in order to do our experiment today. Okay, Ariana, just close out of it and you can just watch. And again, everything will be in the recording, okay? So if you're having issues, it's better for you just to be able to watch, okay? All right, cool. All right, guys, so here is our lab right here. What's really important to know is that when we do our lab, Annalise, we're not focusing on it right now, but I can send you that link as well. So here's the link to the attendance quiz, okay? All right, so what you need to know here is that we need to go ahead and check off all of these boxes. So underneath show, make sure you check off all of these boxes, okay? Then you also need to make sure that you have the rulers ticked off. So we're going to go ahead and click where it says ruler, okay, because we do need to be able to get measurements today. And then the last thing is you'll be able to see that right now our lever is being supported so that it doesn't tilt. We're going to go ahead and click this button at the bottom so that it's able to tilt. Okay, so that removes those little columns so that we can actually use our lever. All right, so we can see a whole bunch of things here on the right side. We've got some bricks that we can use. We've got some, a boy, an adult man that we can use here. We've got a little girl. We've got an adult woman here. And then there are some mystery objects. We won't use the mystery objects today, but you can play around with those on your own if you want. But we have a lot of different objects that we can use. Okay, smiley faces if you feel like you understand the parts here that you need to make sure are set, the settings for this. Awesome. Okay, guys. So I'm going to go ahead and jump back here really quickly. Okay. And so here's what is going to happen. Okay. So for question number one, again, make sure you have the settings as I showed you. And question number one asks us to take the 5 kilogram bricks and put them at each of the locations listed in the lab report on the left side of the lever. On the other side, we're going to place the 10 kilogram bricks and figure out where those bricks need to be in order to balance the beam each time. So that data, we're going to go ahead and put it in our lab report. Okay, and I'm going to do question number one with you because question two is similar. So you'll have to do question two on your own, but question one we're going to do together. And then what we'll see is that there is no instructional video. This is the instructional video, Brianna. This is the video I'll upload later. Okay. The data in part number two is, the data in this part is going to have a pattern. And what we're going to see is we're going to make a prediction based on the pattern that we see about where we would need to put the 10 kilogram bricks to balance the lever if the 5 kilogram bricks were placed 4 meters from the center. Okay, so don't freak out about this, guys. I'm going to go ahead and show this to you right now. Okay, all right, sorry, let me go ahead and jump back over here again. All right, so looking at our lab, sorry, I'm going to actually have these side by side, maybe. Sorry, guys, hold on one second while I work on this. Okay, so question number one, again, you can see the data here. Okay, you're going to type your answers into the box just like I do. Okay, so on one side, the 5 kilogram bricks, it says the first time they need to be 0.5 meters away from the fulcrum. So I'm going to take the 5 kilogram bricks, I'm going to click them and drag them and put them at 0.5 meters away. Okay, smiley faces if that makes sense. I grade them by hand, Annalise. That's why it always takes a little bit of time for you to get your grade back because I have to grade them by hand. Okay, all right, so we've done that. Now we need to figure out where did the 10 kilogram bricks go. So I'm going to grab the 10 kilogram bricks, and on the other side, I'm just going to try every single one. Okay, so that did not balance it, right? So I'm going to go ahead and move it in a little bit more. Still not balanced. Move it in a little bit more. Still not balanced. Keep on going. Nope. All right, now it's balanced. All right, what do we see here, guys? Tell me in the chat box. What are you seeing here? Where do the 10 kilogram bricks need to be in order to balance off the 5 kilogram bricks? Sorry, let me make it bigger for us again. Yeah, they need to be at 0.25 meters. Exactly. Okay, guys, so we're going to go ahead and over here, we're going to fill in 0.25 meters. Okay, make sure, guys, that you use your, sorry, I'm going to make this darker. Make sure that you guys use units, okay? So 0.25 meters. So everybody should have this in their first question. Okay, give me a smiley face if we have filled in this first one. Okay, you guys are getting the same exact data than I am. Excellent, perfect. Okay, next one. It says now we're going to move the 0.5, the bricks, the 5 kilogram bricks to 1 meter. So I'm going to go ahead and move these over to 1 meter. And now same thing, I need to go ahead, I need to move the 10 kilogram bricks to each tick until I find where they balance. Okay, so I'm going to move this. And that was pretty easy, they're balanced now. So where does the 10 kilogram bricks need to go in order to balance off the 5 when the 5 is at 1 meter? Yes, 0.5 meters, exactly, 0.5 meters. Perfect. Okay, so now we're going to do the next one. So if we put the 5 kilogram bricks at 1.5 meters, just like the third line says here. Same thing, I'm going to go ahead and move over my bricks. And that was super easy. They're balanced off. So where did the 10 kilogram bricks go? Are you guys feeling pretty confident about these? Yes, you are copying my answers for number 1. Please copy these answers. Okay, you could do it again on your own, but you'll get the same answers. So there's no point in doing it twice. Where do the 10 kilogram bricks go? Yes, make sure you use those units. I appreciate it, Brianna. No naked numbers, 0.75 meters. Okay, and then last but not least, we're going to go ahead and grab those 5 kilogram bricks, put them at 2 meters, and then I'm going to move around my 10 kilogram bricks. Oops, nope, that wasn't it. Sorry, try. Ooh, hello, come back. There we go. Where do the 10 kilogram bricks go? Where do the 10 kilogram bricks go? One what? Make sure we use units. I want to see units in our answers. Yes, thank you, Haley. Thank you, Andrew V. Yes, we need to be at 1 meter. Exactly, 1 meter. Sorry, let me make that a little bit darker. Okay, give me a green check once you have all of your yellow squares filled in. Green check once we have all of our yellow squares filled in. Again, you should have the same answers as me for this part. Awesome, looking good. All right, green checks, Adrian, Annalise, Anthony. Ariana, you can take a picture of it and give me a green check. That might work so that you have it saved for later. Ciara, Dalen, Libby, Eric, green checks, Jacob, Jasmine, Melissa, D-Bob, Tyson, Zoe O. Make sure I have your green checks. Good. Okay, guys. So this actually follows a pattern. So what I want you guys to notice is that 0.5 meters, if I were to cut that in half, that would equal 0.25 meters. If I were to take 1 meter and cut it in half, what would I get? If I take 1 meter and cut it in half, what do I get? 0.5 meters, which you'll notice is the same thing here. What if I take 1.5 meters and cut it in half? Yep, exactly. What you see right here is 0.75 meters. And lastly, what if I take 2 meters and cut it in half? 1 meter, exactly. So what you'll notice is that the 10 kilogram bricks always need to be half the distance away as the 5 kilogram bricks. Smiley faces if that makes sense. I'm going to type that right here. Okay, the 10 kilogram bricks, you don't need to type this. This is just a note. 10 kilogram bricks always need to be half the distance away as the 5 kilogram bricks. Okay, so this right here is our pattern. Okay, so based on that, guys, let's think about this. If I were to put the 5 kilogram bricks 4 meters away, where do you think the 10 kilogram bricks would need to be? Think about half the distance. If over here I had 4 meters, what would it need to be on the right? If over here I had 4 meters, what would it need to be on the right? Yes, exactly. They would need to be half of 4, which would be 2 meters away. Okay, smiley faces if that makes sense. Okay, so this should be your answer for number 1. You should save your answer to number 1. Okay, make sure you have all of these all of these yellow boxes filled out, as well as the red part filled out, 2 meters away, and then you're going to save your answer. That's number 1. Okay, easy peasy, right? We automatically just got 3 points. Smiley face if that makes you happy. You've automatically gotten 3 points. Yeah, awesome. Okay, good. All right, so question number 2 is going to have you do the same exact thing, but this time with the 10 kilogram bricks and the 20 kilogram bricks. So 10 kilograms on the left, 20 kilograms on the right. So this one is exactly the same, just with different weights, okay? Different masses. So on the left, we'll put the 10 kilograms at 5 meters, and then on the right, you'll be using the 20 kilograms to try to level it off. Okay, I am not going to do number 2 for you. I already did number 1 with you. Number 2 you should be able to do on your own. It's exactly the same process, just with these weights now. Smiley faces if you feel good about that. Smiley faces if you feel like you are capable of doing number 2 on your own. Awesome. All right, so again, same thing. Fill out the purple boxes and then make sure that you answer the red question. All right? All right, so that's number 2. Now, number 3 is going to have us balance off a child and an adult. Okay, so I'm going to go ahead and show you what that looks like. All right, so we did question number 1, we did question number 2. Question number 3, we have when you use that little box on the right and you scroll to the right, you can see that there's a little boy and an adult man, and there's also a little girl and an adult woman. And what we're going to try to do is we're going to take both of those and we're going to set them on opposite sides of the lever, and we're going to try to balance them off. And we need to figure out where we need to place them to balance it off. Okay, and then there is an analysis question that I will take a look at with you in a few moments. So let me go ahead and share with you what this looks like. All right. Sorry, let me make this smaller. Perfect. All right, here we go. So I'm going to go ahead, I'm going to get rid of these bricks, just drag them off and let go. And now we're going to work with the blue ones are the adult man and the boy. So we're going to go ahead, grab the boy. I'm going to put him on one side. Let's put him at 1 meter. And now I'm going to go ahead and grab the adult man, and we're going to put him on the other side, okay? Is this balanced? Yes or no? Is this balanced? No. Okay, so same thing. We're going to move him around until we can get it balanced. Tell me when to stop. All right. Where does this balance off? Where does this bounce off? Okay, if the child is at 1 meter, okay, so I place the child at 1 meter. Okay, then the adult would need to be exactly at 0.25 meters. Awesome. So that is definitely correct. Now, what I do want you guys to notice is that you might need to move these around and test these a few different times, okay? Because there is actually another point at which there's actually another 2 points at which they do balance, right? So let me go ahead and show this to you. Okay, so for example, if I moved the boy over to 1.5 meters, I could still balance off by putting the man at, oops, sorry, no, that's not it. Maybe it was 2 meters. I can still balance off by putting the man at 0.5 meters. Okay, so there are multiple ways in which we can actually balance these off. I'm showing you an example of each type of question, Adrian. Yeah, so I'm giving you the answers, Annalise. So the parts that I'm giving you the answers for, you should copy, but you will be expected to do the other parts on your own. Smiley faces if everyone understands that. Smiley faces if everyone understands that. Okay, perfect. All right, so you could have another answer, right? You could say that the boy could be at 2 meters and the adult could be at 0.5 meters. Okay, so that could also be an answer that I would give credit for. Okay, yep, you can copy this. Okay, so you should either put here 1 meter and 0.25, or my second option was 2 meters and 0.5, or sorry, 0.5, yes. Okay, so that would be our second option here. Okay, smiley faces if that makes sense, question marks or confusion faces if we don't understand that, what I just put here. Awesome. Okay, now you would do the same exact thing with the adult woman and the girl. Okay, so we would drag these guys off, and then I would place the girl somewhere, and I would grab the woman, and I would do the same thing, test it out until they're finally balanced. Whatever answer I get, that's what I fill in here. And again, there's more than one possible answer. So try to play around with it. You might get a different answer than someone else, but that's okay because there's more than one answer that works. Okay, I'm not going to do number 2, I'm not going to do the green boxes for you. I already did these ones for you, right? So 0.25. Okay? Now, so you need to do the green boxes on your own. Now, the next part is it asks you, based on these results, does a lighter object with less force, right? A lighter object has less force. Does it need to be closer or further away from the fulcrum than the heavy object that has more force on the other side? So let's take a look at this, right? Let's go back to the little boy and the man. All right, so here we go. Okay. So the lighter object with less force is which one? The boy or the man? Who is the lighter object with less force? Yes, the boy is the lighter object with less force. And does he need to be closer or further away from the fulcrum than the man? Does he need to be closer or further away? Yes, he needs to be further away. Yes. Remember, more distance allows a lighter force to pick up a heavy object. We've talked about that a whole bunch. So right here, to balance a heavy object that has more force, the lighter object with less force needs to be further away. Further away. All right, so that should be question number 3. Okay, smiley faces if we feel good on that. Smiley faces if we feel good on that. Again, you do need to do the green boxes on your own, and your green boxes should still prove this statement. If your green boxes don't prove this statement, you did it incorrectly. You need to make sure you do it correctly. Okay, so make sure you save number 3, since we answered number 3 together. All right, now number 4 and number 5 are going to actually have us use that equation that we learned at the beginning of class. So let me go ahead and show you what this looks like. I'm going to jump back to our PowerPoint here. Sorry, we're done using the virtual lab right now. Can I get a thumbs up if we feel good about doing questions 1 through 3? Thumbs down if we have any confusion about questions 1 through 3, because question 4 and 5 I'm going to do on the board with you. Awesome. Okay, so here we go. A 10 Newton object is placed 3 meters from the fulcrum. Okay, so newtons, what does this tell me again? Is this force or distance? Force or distance? Yes, this is going to be our force, and specifically this is going to be our first object, so I'm going to call this F1. All right, and it's placed 3 meters from the fulcrum. What does meters tell us? What does 3 meters tell us? Yes, it's going to be our distance, exactly. Specifically, again, the distance for the first object, D1. And what we want to know is on the other side, what distance would an object need to be if it weighed 15 newtons? Okay, so our distance here, D2, this is what we're trying to figure out. We don't know it yet. And this 15 newtons, again, newtons tells us force. So this is our second force on the other side. So I'm going to go ahead, I'm going to fill this in with us so that we have this. Again, you do need to show your work. You'll see this exact setup in your question number 4. So you need to make sure you fill it in as you see it. Okay, so force number 1 is our 10 newtons. Okay. Distance number 1, it's because it's the first object, right? This is just the first object, and so that's why I called it F1. Yep, exactly. Whereas this one down here is our second object, so I called it F2. Awesome. Our distance number 1 we said was 3 meters, right? And our second force for our second object was 15 newtons, right? I'm just showing you what we already filled in. Yeah, so this is what you should have for question number 4. It should look exactly like this. Sienna, you can put units if you want. I just find units can be a little bit confusing when we show our work. So at least at the end, make sure you have your units. I won't penalize you for not having units in the middle part, just as long as you have your units for your answer. Okay, so the first thing that you're going to do, guys, is you're going to multiply 10 times 3. Don't tell me what that equals right now. That is something that you should be able to figure out and put right here. Okay, smiley faces if you understand. 10 times 3, you should put that answer right here because we can do that. Awesome. This 15 is going to continue to move down here because we can't change it yet. But remember, to get rid of a number next to our variable, we need to do the opposite function. So what would be the opposite of multiplying by 15? Yes, we need to divide by 15, but whatever I do to one side, I also need to do where? Whatever I do to one side, I also need to do where? Yes, on the other side as well. So whatever answer you get from multiplying 10 times 3, you then need to divide it by 15, and that will give you your answer. And your answer should have what units? Answer should have what units? Distance, distance. Answer should be what? Should be with meters, meters, exactly. That should be our answer for number 4. Okay, smiley faces if you guys feel like you can do number 4 on your own. I know it's algebra, but I walked you through it. We should know how to do it. Excellent. All right, so number 5, really quick, let me show you this one. So number 5 has a mystery object that's placed 6 meters from the fulcrum. So this is our first distance. So I'm going to call that D1. To balance it, on the other side, we have an 18 Newton object. So that's the force of the second object, so F2. And it's placed 2 meters away on the other side. So that's our second distance for our second object. That's D2. And we want to know what must be the weight of the mystery object. So the mystery object, again, that was our first object. And we want to know the force of it. So F1. Yes, exactly, Dolly. For this one, you need to make sure you put meters or M after your answer. Exactly. Okay, so I'm going to fill this in with, so our D1 was 6, our F2 was 18, and our D2 was 2. Smiley faces if you understand how I got here. Smiley faces if you understand how I got here. I know I'm going a little bit quick, but we only have 2 minutes left. I know it looks hard, but it's not too bad. Okay, so we have our first distance filled in. Remember, the weight is what we're trying to figure out, so we leave it as it is. Our second object weighs 18 newtons, and its distance is 2 meters away. So I filled that in. All right, so we can't multiply F1 times 6, so I'm going to keep that the same. But we can do 18 times 2. So whatever 18 times 2 is, that's what we're going to put in this blank. Okay, don't tell me what that answer is right now. You need to do that on your own. And then last step, we need to get rid of this multiplying by 6. How do I get rid of multiplying by 6? How do I get rid of multiplying by 6? Yes, we are going to divide by 6. And whatever I do to one side, I also need to do where? On the other side, exactly. So what we're left with on the left is we'll be left with our F1. And on the right, we'll take that first number that we multiplied, divide it by 6, and that should be our answer here. This is a force, so our units should be what? If this is our force, our units should be what? Whenever we have a force or a weight, our units should be what? Yes, we should make sure that we have our number and it ends with N or newtons. Okay, smiley faces if you guys feel good about number 4 and number 5. And again, this will all be in the recording, so don't freak out if you don't remember it completely right now. The recording will be posted. No, Annalise, you got this. I believe in you. If you still have any issues, guys, you can come to support sessions tomorrow or on Monday, and I can definitely help you out with that as well. Okay? It's not scary, guys. Just follow it step by step with the recording once it's posted. Awesome. So this was our objective for today. Make sure that you guys complete the parts that I didn't do with you on your lab. Once I give you the last word, go ahead and submit the attendance ticket right now. But your lab is technically due at 4, but again, don't freak out if you have to turn it in a little bit late. I care more about it being done correctly than it being in exactly at 4 o'clock. So just get it done correctly. Awesome, Kim. Love to hear it. Here's your last word, and I will see you all later. Have a wonderful day, everyone. Go ahead, log out. I do need to go to my next class. Bye, everyone.